Hello everyone. So welcome to another video. In this video, we're going to solve the theory questions of statistics of 2023 paper. So let's see. The first question is differentiate between mutually exclusive and independent events. I had already covered this question in my previous videos, so we're not going to discuss this here. Second question, state the central limit theorem and what is its significance in the sampling process. So central limit theorem states that given a sufficiently large sample size, the sampling distribution of the sample mean will be approximately normal distributed regardless of the shape of the population distribution from which the samples are drawn. And this approximation improves as the sample size increases. Now what are the significances in a sampling process? The significance is normal approximation. The CLT allows us to use normal probability technique to make the inferences about the population parameter even when the underlying population distribution is not normal. Basis of statistical inferences, the CLT underpins many statistical methods like hypothesis testing and confidence interval, and it justifies the use of z-squares and t-squares in inferential statistics. Sample size consideration, the theorem provides the guidance on the necessary sample size for achieving a normal approximation. Although there is no strict rule, a common guideline is that a sample size of 30 or more is typically sufficient for the CLT to hold. Robustness, the CLT demonstrates the robustness of statistical method. As long as the sample size is large enough, the results will be reliable even if the original data does not follow a normal distribution. Practical appliances, so this can, in the field of quality control, finance and social sciences, the CLT allows to analyze sample data and make predictions about population with confidence, facilitating decision-making process. So we have to first explain the CLT, central limit theorem, and then significances are normal approximation, basis for statistical inferences, sample size consideration, robustness, and practical appliances. Moving to the next question, that is, list and describe the criteria of a good estimator and what role does consistency plays in determining sample size. So the first part of this question is already covered in my previous videos. So moving to the next part of this question, that is, role of consistency in determining sample size. So consistency plays a very crucial role in determining sample size because it assures that as we collect more data, our estimates will coverage to the true population parameter. The very first is coverage assurance. If an estimator is consistent, increasing the sample size will improve the accuracy of our estimates. Trade-off between sample and variability. So larger sample size typically reduce the variability of estimators, that is the standard errors, thereby enhancing consistency. Statistical power. In hypothesis testing, a larger sample size increases the power of statistical test. Cost-benefit analysis. While large samples lead to more consistent estimator, they also came with increased cost. So researchers must balance the need of consistency with practical consideration regarding sample size. So we did explain the role of consistency in determining sample size. These are coverage assurance, trade-off between sample size and variability, statistical power, cost-benefit. Moving to the next question, that is distinguish between parametric and non-parametric test, and under what circumstances do we need to use non-parametric test. So also the first part of this question is covered in the earlier video. So we're gonna do the second part, that is the circumstances for using non-parametric test. So the very first is when the data does not follow a normal distribution, when it's an ordinal data, and when there is a sample size, when there is a small sample size, and when the sample includes heteroscedity, presence of outlier, and data measurement level, when dealing with nominal or categorical data where traditional parametric tests cannot be applied. So these are the circumstances for using non-parametric test. The first is non-normal distribution, ordinal data, small sample size, heteroscedity, presence of outliers, and data measurement level. So this is all for this video. Please do like, subscribe, and share the channel. Thank you.